Hey guys, Dr. Tim Kruse teaching some algebra. Today we're going to demonstrate how to solve exponential, that means it has an exponent, and log equations. All right, so exponential means that there is an unknown in the exponent. So this is 2 to some unknown number equals 8. I'm going to show you how to solve that when the unknown's up there in the exponent. All right, I'm also going to explain exponential notation. This is called the base, the exponent, and the product. Notice that the base changes on these three, so we have one procedure to solve these when the base changes. We have another procedure to solve these when the base is always 10. And then finally, I'm going to explain to you Eulers number, E. And when the base is E, we have yet another procedure to solve those. All right, so 3 different ways of solving these 9 equations. Now, if I rewrite, we'll get to those in a minute. If I rewrite these exponential equations, equation means equals, exponential means there's an exponent, and we have to solve it because the exponent is unknown. Well, one of the ways that we solve this is we change exponent equation to a log equation. All right, log stands for logarithm, and basically it's just a button on the calculator that we push that tells us what the exponent needs to be. So notice 2 to the x equals 8. If I write it in log form, it's log base 2 of 8 is 6. Here's the base 2, base 2. Here's the exponent all out here by itself. There's the exponent. And here's the product 8, the product 8. All right. So each one of these 9 equations here I've rearranged in log form. We'll go over those in more depth here in just a minute. And then finally, there's log equations. See, these are log equations up here where the exponent is out here all by itself. Those are actually really easy to solve. These 9 here, I'm going to show you, they're very, very simple to solve. But sometimes they move the x, all right? Sometimes the unknown is not the exponent like it is here. Sometimes the unknown is the product. And we got to figure out what the product is, all right? It's just another way of solving. Instead of pressing a couple of buttons on the calculator and getting x, well, we have to work a little bit harder on these, but they're basically the same equation. So log base 2 of 8 equals x. So if I say the exponent is unknown, I put the x there. But what if I say the 8 is unknown? Well, then it would look like this. Log base 2 of, that's an 8, but we're going to say it's unknown, equals 3. So these 9 equations written with the product unknown look like this. They're all the same equation. We're just going to work on these 9 equations written in different forms. All right, so let's talk about logarithm a little bit. We use logarithms to solve for unknown exponents. That's the only thing, in this class that we're going to use a logarithm for. You're not ever going to press the log button unless you're looking for an exponent. All right, that's what the log button does. If you're pressing the log button, you're basically saying, give me the exponent. So I like to tell students, look at that log button. It's on the left side on your graphing calculator about halfway down. Look at that log button and pretend that you taped over it and you taped the word exponent over it. So when you're pressing the log button, just pretend you're pressing exponent button and you're just telling the calculator to give me the exponent. So when you press log, just pretend you're saying, give me the exponent. So for example, that first equation, 2 to the unknown exponent is 8. Now I gave you a pretty simple one here. That's going to be a 3. 2 to the third power is 8 because 2 times 2 times 2. 3 2's all multiplied together give you 8. So we're starting out with, with baby steps. I gave you an easy one here, but let's say we can't see that that's obviously 3. How do we figure it out? Well, if the exponent is unknown, that's your signal to automatically change this exponent equation to a log equation. So I must change it to a log equation. Now the log equation follows the same form every time. You write lowercase log for logarithm. All right, next comes, it's called a subscript, where it's like an exponent down low. Next comes your base. They need to know kind of what language you're speaking. It could be base 2, base 3, base 10, base E. It could be any base. It's kind of like, what language are you telling the calculator to speak? Go over here. This number right here is your base. All right, so base goes down here, and now it's small. Next comes your product. Remember I said 2 times 2 times 2 is 8. Well, that's the answer to a multiplication problem. When you multiply a bunch of 2's together, you get a product. So your product comes next. All right, so log base 2 goes there, it's little. The product is regular size, and then equals, and then you put your exponent out here all by itself. Now the exponent was small, it was a superscript up high and small, and now it's regular size. Okay, so log base 2, whatever this number is that's being raised to a power, that's your base. Log base 2 of your answer, your product, 8, is your exponent. You're just kind of reorganizing to get the exponent out here by itself. Because once I get the exponent out here on the right side of the equal sign all by itself, well, now I just press a bunch of buttons and I can figure out what this is. I can figure out what that exponent needs to be. All right, so I'm ready to put this in my calculator now. I've rewritten the exponent equation, turned it into a log equation, and now I just have to put this in my calculator and it will tell me what the exponent needs to be over here. All right, using the TI-84 is the easiest way. So using the TI-84, you're going to start by pressing the math button. You're going to choose A, which is log base, which brings up this picture with the little squares, and you just pop in the numbers. Let me show you here. All right, TI-84, whoops, let me get it right there. All right, let's start by pressing the math button. Let's start by turning it on, clear that. Here's your math button over here, so math, and then down to option A. So you got to scroll down quite a ways. Whoops, too far. There it is, log base, option A, it's after 0. Choose that, and it brings up a nice picture where basically this calculator, the 84, basically speaks any language. Remember I told you the base is kind of what language you're speaking. So it'll speak base 2, base 3, base 5, base 10. It speaks any language, which is a cool benefit of the 84. So I'm going to tell it I'm speaking base 2. That's my language. And now it wants to know, well, what do you want the answer to be? What do you want the product to be? I want the answer to be 8. Now tell me what exponent goes on that 2. So I hit enter, and it tells me, oh, well, you need to put a 3 on that 2. So you're basically saying, hey, here's the base. 2 to what power gives me this answer 8? So you're telling it what language you want to speak, what base you want, and you're telling it what you want the answer to be, and it'll figure out what the exponent is. All right, let me show you how to check that, and then I'll show you how to do it on the 83. So what we came up with is log base 2 of 8 is x, and then we put in the calculator, and the calculator told us that that x needs to be 3. All right, so there's our answer. Now how do we check it? We come back over here and we change it back to the original exponential equation. 2 to the x equals 8. Let's put 3 in there and see if it works. So here's our original equation. 2 to the x equals 8. I popped in 3, and my question is, does the left side still equal the right side? Does 3 work? So I put this in my calculator and I get 8. I'll put it on the left side. On the right side, I just have 8. I drop it down, and then I check my equality. Does the left side equal the right side? Check. Yes, it does. That works. All right, over here, the 83, we have to use a trick. It's called change of base. All right, 83 is a little harder to put it in. We want to put the log of the 8, and we want to divide by the log of the 2. That's a trick called change of base. It'll make more sense later, but this log has a base of 10 that we don't write. We'll talk about it later. And this log has a base of 10 that we don't write. What that is an easier language. Base 2, base 3, base 4, those are hard languages for the calculator to understand. But if I change the base or the language to base 10, well, then any calculator can do it, even like a scientific calculator. So it's called the change of base formula. I do log 8 divided by log 2. So on the 83, you got to put it in like this, log 8 divided by log 2, and you'll still get 3. You just have to use the change of base trick to do it on your calculator. All right, so let's work a few more, and I'm going to do the whole assignment like this. I'll have exponential equations on the left, equations equal sign with exponents on the left, and I'll have log equations, log equation equals means equation. I'll have those on the right. So sometimes we'll be handed an exponential equation and we'll have to change it to a log to figure it out. And sometimes we'll be handed a log equation and we'll have to change it to an exponential equation to figure it out. But let's start with this one right here. 3 to the x equals 1. That's an equation. I have an unknown exponent. That's your signal. to automatically use your log button. All right, so let's come over here, and instead of an exponent equation, let's write the same thing using logs. So I start with log, lowercase log, for logarithm. I put the base right here. That's the language we're speaking. We're speaking base 3. And then I put the answer right here, the product. All right, so I'm telling the calculator, I want you to speak base 3, and I want the answer to turn out 1. So tell me what the exponent is that needs to go on the 3. All right, put this in using the method on your calculator. You guys on the 84, you'll do log base. You guys on the 83, you'll do log 1 divided by log 3. All right, and you'll get x equals 0. So naturally, we want to check that and make sure it works. If you want to check it, just take your 0, put it in for x, just plug it back into your original equation. So 3, plug in 0 for x, and we want to see if it equals 1. So just check the left side, check the right side, and then check and make sure they're still equal. So as we work that out, plug in 3 to the 0 in your calculator, it's going to tell you 1. So the left side is 1. The right side was already 1, so I just dropped it down. And then just check your equality. And just make sure the left side equals the right side. If it does, check, you got the right number. All right, next is 7 to the x equals 1.828. I'm just working off those problems on the first page. All right, unknown exponent. That's your signal to change this exponent equation to a log equation. All right, so I don't know how to solve this. I don't know how to solve for unknown exponents. I need to change it to a log and make the calculator find that exponent for me. So I start with log, and then I got to tell it what language we're speaking. We're speaking base 7, and I'm going to tell it what the answer is. The answer needs to be 1.878, all right, my product. So what I'm telling the calculator is, hey, start with base 7, speak base 7 for me, and give me an exponent that will give me this answer here. So we're giving them the base, we're giving them the answer, and the calculator is going to figure out what that exponent needs to be. Put it in using your method for your calculator, and you should get x equals 0.31, which again, of course, you're going to want to check. So to check it, just go back to your original, take out x, put in your answer, see if it works. Check the left side versus the right side. So on the left side of the equal sign, I say 7 raised to the 0.31. My calculator tells me it's 1.828. I go over to the right side, I drop that number down, and then I just check for equality and make sure these two equal. If those two equal, yeah, then 0.31 works. All right, so we've kind of worked through how to solve these equations here where the language or the base keeps changing every time. Now let's take a look at these guys here where the base is 10. All right, so if I'm given the exponential equation, there's the exponent, there's the equals, exponential equation, and the exponent is unknown, that automatically signals to me that I need to change this equation into a log equation and figure it out. Let the calculator figure it out. Now notice that the base on this one is 10. The language that we're speaking is base 10. Base 10 is kind of like, English in the United States. It's the language that everybody speaks. So in math, base 10 is kind of like English. Every calculator speaks base 10. Even the cheapest scientific calculator or even the 4-function calculators out there, they all speak base 10. It's kind of like speaking English in the United States. So base 10, we use that so much, we call it a common log, all right? Because any calculator can speak base 10. So when I change this exponential equation to a log equation, I'm going to take a shortcut. I'm going to be lazy because this is base 10, and we use it so much that we don't write the 10 down there. I have to tell it, what language are you speaking? Base 10. Usually we would put a 10 there, but it's so common, it's a common log, it's so common that we're lazy and we don't write the 10. So if you see a log and there's no base there, it's understood to be 10. Just pretend there's an invisible 10 there. It's understood. So log of 100, I want, log, then put the base here, but if it's 10, don't bother writing it. And then put the answer, the product here, and you're telling the calculator, hey, I want you to speak base 10, and here's the answer. Now tell me what the exponent needs to be. All right, so you're thinking log base 10, but you're not going to write the 10. It's going to look like this. Well, if you have a common log, base 10, you just have to punch this in. There's no tricks. We don't have to use, you know, the change of base formula or any of that stuff. Any calculator in the world will do log 100 as long as it has a log button on it. So you don't use any tricks. You don't have to use log base. You don't have to use log 100 divided by log 10. That's just kind of overkill. You just hit log 100. So you grab your calculator, and remember the log button on your calculator is designed for base 10. So no tricks. Just press log 100 and you get 2. All right. So log 100, hit enter, and you get 2 automatically. No tricks, no log base, no log 100 divided by log 10. Just press log 100. Common logs are super easy to figure out. So we're saying the exponent needs to be 2, and of course we want to check that. So let's take it back to the original equation. It was 10 to the x equals 100, and we think that x is 2, so let's check that. Put this in your calculator, it's 100. Put that on the left side, so 10 squared becomes 100, and this was already 100. Drop it down and then check it for equality. As long as both sides are the same, you're checked. All right, now let's look at this one. So I'm given the exponential equation. I don't know the exponent. I notice that it's base 10. That means it's going to be an easy one. That means it's a common log. That's like speaking English, all right? So when I write it in log form, I write log. I don't have to tell it what language because it's 10, all right? That's a common log. Everybody knows base 10. So by leaving that out, I'm automatically telling everybody that there's a 10 there. And then I give the answer 100,000. So I'm telling the calculator, hey, speak base 10. Here's your answer. Make it work. Tell me what the exponent is that makes it work. If it's a common log, no tricks. Just hit log 100,000. It'll tell you the exponent needs to be 5. Well, let's come back over here and check it. Put a 5 right there. Check the left side versus the right side. 10 to the 5th, that's 100,000. Drop it down. 100,000 was already there. Drop it down. Check for equality. Good to go. All right, next one. 10 to the x equals 2.138. Again, we're speaking English here. Base 10 is like speaking English. This is a common log. So I'm going to write log. I'm going to leave the 10 out. If I leave the 10 out, everybody knows it's base 10. Just pretend there's an invisible 10 there. Everybody knows there's a 10 there. It's understood. And then tell the calculator what the answer needs to be. So you're telling the calculator, speak base 10. Here's the answer. Make it work. Tell me what the exponent is. And it'll tell you 0.33. Check it. Plug it back in. 10 to the 0.33 is 2.138. On the right side, drop it down. Check and make sure they're still equal. All good. All right, so we've solved these exponent equations where the base keeps changing. We've solved these exponent equations where the base is 10. We call that a common log. We like that because it's real easy to calculate on the calculator. And now let's look at these guys here where the base is e. That stands for Eulers number. It's a weird irrational number like pi. All right, you remember pi is 3.14. Well, this is kind of like it. This guy Euler came up with this number, and it's roughly 2.72 if I just kind of round it. All right, so don't be scared of e, Euler's number. It's just 2.72 roughly. All right, so given this e to the x, now it looks like this number is unknown, but we know what e is. It's 2.72. Just like pi is 3.14 and it goes on forever, e is 2.72 and it goes on forever. So this is not unknown. We know what that is. We don't know what the exponent is. So this is 2.72 raised to some exponent gives us this number here. All right, notice the base is e. That's a number. We just don't want to write down all the digits. It's 2.7, it's actually this number right here, which I was getting ready to show you. 2.7, 1828, 1828, 4590, 45, and it goes on forever and ever and ever. All right, so this is a number. It's 2.72 and a whole bunch of other stuff. We don't want to write this down every time, so we just write down e, and the calculator remembers all of these numbers for us. So notice that it's base e. E stands for Euler. Looks like Euler, but he pronounces it Euler. He came up with this number, and we call it a natural log. All right, I have an exponential equation. I have an unknown exponent, so I need to change it to a log equation. Now we use a special button. This is another button on your calculator below your log button. If you look below your log button, you're going to see an LN button. That's an L, not a 1. It's lowercase. Lowercase L, lowercase n for natural log. I don't know why they spell it backwards, but it's natural log. All right, and natural log is just an abbreviation we use because we don't want to write the e. We're being lazy, like on the common log where we didn't write the 10. We're being lazy again. We don't want to write e. All right, we use it so much that we said, hey, let's quit writing the e here and let's just put an ln there and call it natural log, and then everybody knows that there's an e there. So just pretend there's an invisible e there. The e is understood. Everybody understands that if you see ln and you don't see anything there, it's automatically an e. So I'm saying, what's the natural log of this mess right here equals x? I'm asking, what's the exponent? What's the exponent that goes on the e to give me this number here? So think natural log base e of this mess equals x, but we're lazy. We're not going to write the e. It's understood. We're going to leave that e off. So don't write the e. Just write natural log, boom, and put it in your calculator. And again, this is one of the easy ones. We have a natural log button. All right. The natural log button is designed. The natural log button is designed for base e. So we're just going to write it like this without the e. Everybody knows there's an e right there. And we're going to punch this in with our natural log button. Looks like ln. It's right below your log button on your calculator. No tricks. All right. Just press in natural log and then that mess. And it should tell you the exponent needs to be 1. All right, let's check it real quick. So go back to your original equation. Our original equation says e to the unknown exponent is this mess right here. You said x needs to be 1. Let's try it. So put in e to the 1. Your calculator will give you this mess here. And drop down the mess on the right. Check the left side with the right side. Make sure they're equal. Yes, they are. All right, the reason I did this problem is I wanted to show you what e is. All right, pi is 3.14159 ... goes on forever and ever. We just say 3.14. Well, e is 2.71828 ... goes on forever and ever. It's called an irrational number. You know, it goes on forever and there's no really rational pattern to it. So roughly it's just 2.72. So don't let, if you've never seen e before, Eulers number, don't let it freak you out. Just call it 2.72. Just like you call pi 3.14, call e 2.72. Okay, so given this equation, unknown exponent, if it's an exponential equation and I don't know the exponent, that's your signal to change it to a log. So base e means it's going to be a natural log, means we're going to write ln for natural log. We're not going to write e for the base or the language that we're speaking. We're going to leave the e off, it's understood, and we're going to tell them what the answer needs to be. So we're telling the calculator, hey, it's 2.72, and I want the answer to be 1. Tell me what the exponent is that I need to put on that e, that 2.72. No tricks, just punch it in, natural log 1. It says, hey, your exponent needs to be 0. Let's check it. Back to the original equation, put a 0 right there. Left side, you put this into your calculator, it says 1, drop it down. There was already a 1 on the right side. Check for equality, you're good to go. And then e to the x equals 6.281, just making it a little bit tougher instead of those nice easy exponents. All right, natural log, because it's base e, so just write ln, and then you don't have to write the e. So we don't tell it what language we're speaking. It already knows. If it's a natural log button, it knows it's speaking base e, base 2.72. We tell it what we want the answer to be, and then it goes and looks for the exponent. So punch this in. It says the exponent needs to be 1.837. Check it. Put it in right there in your original equation. Raise e. Now e is above your natural log button on the calculator. It's the second function of your natural log button. And you'll see e raised to a power. Well, if you put 1.837 into that power, it'll tell you 6.281. Let me show you real quick. All right, I'll show you on the 83 here, but it's in the same place on the 84. Right here's your log button. Here's your natural log button. All right, there's your e. So it's the second function of the natural log button. So second function, e, looks like that, and it's waiting for an exponent. So 1.837, close the parentheses, enter, and there it is, 6.281. Now notice it is off just a little bit. That's because I was rounding in the middle of the problem. And I told you guys a lot, don't round in the middle of a problem, but I did. See, I punched this in. Let me back up. So natural log 6.281, natural log 6.281. Close the parentheses, equals. All right, I rounded that. And if I'm going to plug that back into another equation, I really don't want to round that. It kind of messes up my answer. So if I use the exact number over here, if I raise e to that exact number, oh no. So if I raise e to that exact number, let me try it here, e raised to the 1.837529203. I think I got that in there right. It'll get me a closer approximation. Now it looks more like 6.281 when I round it, all right? So I was off a little bit because I rounded in the middle of the problem like I told you guys never to do. So when you're plugging it in to check, I mean, I'm glad I made that mistake. When you're plugging it in to check, don't use the rounded answer. Use the exact answer that your calculator told you. If you use the rounded answer, you'll come up a little bit off like you just saw me do. All right, so you guys know how to do most of this already. So we worked through all of these. All right, we changed it to log, we changed it to a common log, we changed it to a natural log. So we changed all these exponent equations to log equations and solved them. All right, now in the process, we worked out these problems here. When you guys were like, when you changed it to a log problem, then it looks something like this. And we punched natural log of that mess and got an answer. We pressed log of 100 and we got 2. And then we used our change of base formula or our log base to find out that this was going to be a 3 on that 2 to get 8. All right, so we've learned how to do all of these right here. Let's look at our last set of equations here. And I want to solve log equations. Now these were log equations up here, but notice the difference. Look at where the x is and look at where the x is here. All right, so sometimes they trip you up by putting the x where the answer goes. All right, so think about that. We like these, all right? The log base 7 of 1.828 is x. I like that because I'm just going to grab my calculator and punch those numbers in, and it's going to tell me what that x is. So those are, once they're set up like that, those are super easy to do. Just put it in your calculator, put it in your calculator, put it in your calculator, and it tells you what all the x's need to be. But sometimes they rearrange the equation, and maybe it looks like this, all right? So it says log, if you're speaking base 2 and you put an exponent of 3 on the 2, what's your answer? They're not telling us what the answer was. Up here, I knew what the answer was. I said, hey, speak base 2, and the answer is going to be 8. You tell me what exponent goes on that 2. Or speak base 10, and I'm going to tell you the answer is 100, and the calculator will go find the exponent that needs to go on that 10. Well, these are rearranged here. They're not telling you the answer, all right? And they're telling you what the exponent is. So go back to like the first page of our notes when I said we use logs when the exponent is unknown. Like up here, I don't know the exponent, don't know the exponent, don't know the exponent. If they write it like this, they're telling us what the exponent is. This is the base, this is the exponent, this is the answer. That's your product. If they tell you what the exponent is, we don't need a log equation. We need to go back to an exponent equation. All right, so look at this guy here. Here's the equation I just pointed out to you. Log base 2 of x equals 3. That's a log equation, so I put it over here on the log equation side. So I'm starting with the log equation. I'll solve it if I can, but if I can't, I'm just going to take it back over and write it like an exponent equation and figure it out that way. If log doesn't work for you, then just change it to exponent, and usually it'll work out that way. So I'm looking right here and I'm saying, okay, if we know the exponent, then there's no need for a log. I know the exponent is 3. I know that exponent's going to go on the 2. I don't need this log at all, all right? So log base 2 of x equals 3, that's unnecessary. I can't solve it that way. I'm going to go over here and rewrite it as an exponent equation. So this is the exponent. It goes on the 2, so it looks like that, 2 to the 3rd, equals, and then the answer, my product, is right there. Well, this is super easy to solve. Just pop that in your calculator. 8 is x. How do you check that? Again, just put it back into your original. All right, plug the 8 in for x in the original. So if I change that to 8, it says log base 2 of 8, and I want to check and make sure that it equals 3. I just punch this into my calculator. You can use change of base if you're on the 83, or you can use log base if you're on the 84. It's going to tell you the exponent needs to be 3. On the right side of the equal sign, the 3 drops down. Check for equality. There's another one. Log base 3 of x equals 0. They're telling us what the exponent is. I don't need this log. So I'm going to take this over. I'm going to rewrite the log equation as an exponent equation. So my base is 3. I'm going to put a 0 on that 3. 3 to the 0 equals x. This is just calculator work. 1 equals x. Looks like you're done, but you want to check it and make sure. So take the 1, plug it in for x, work that out and make sure it checks. I'll let you guys check that on your own. Log base 7 of x equals 0.31. All right, that's a log. This is the exponent. If I know the exponent, I don't need a log. Let's take it back to exponent equation form. So the 0.31 is the exponent. It goes on the 7 like this, and it equals the x. This is my answer. This is my product. All right, punch that into your calculator, plug it back in and check it. All right, so that's how to work those three. Let's work on these guys here. They have an invisible 10. Remember, if it's log, log, and you don't see anything, that's automatically a 10. If it's natural log and you don't see anything, that's automatically e. All right, so given the log equation log x equals 2, I notice that there's not a base. So I understand that it's a common log, and that's base 10, and we're just too lazy to write it. So there's a 10 there. They told me what the exponent is. They said this 2 goes on that 10. This 2 goes on that invisible understood 10. If I know what the exponent is, I don't need a log equation. I need to take it back over here and change it to exponent form. So I put the 2 on the 10, like that, and it's going to equal my x, my answer, my product. Pop that in your calculator. Looks like 100 is the answer. Go back over here and pop 100 in and make sure it all works out. Log of x equals 5. There's no base. That's log, so it must be a 10, a common log. Put the 5 back on the 10, like that. Set it equal to x, the answer, and work it out that way. All right. You don't need a log if you know the answer. So this is kind of like the second type of log equation. And then finally, log x equals 0.33. I know the exponent, so this whole equation is unnecessary. Just take it back to exponent form. Put the 0.33 on the understood 10, like that, and it's going to equal your product, your answer, x. And then just double check it by plugging it back in and making sure it works. All right, and so now we know how to solve these with a common log base 10. All right, I change it back to exponent form, and I put the exponent on the 10, put the exponent on the 10, put the exponent on the 10. So let's do these last three, and that's all we'll do today. Same thing, all right? They're telling me what the exponent is, so I don't need these logs. I don't need these natural logarithms. So I'm just going to change it to exponent and put the 1 back on the e, put the 0 back on the e, put the 1.92 back on the e. All right, so here's what it looks like. That first one, natural log x equals 1. Note the base is e. It's 2.72, but we don't want to use any kind of rounded number. We're just going to put an e there. Actually, we don't put the e. We understand that e is there. So we understand that weird 2.72 e number is right there. Now, since they told me the exponent, I don't need this log equation. I'm going to change it to an exponent equation. My exponent is 1. It goes on the e, like this. The exponent 1 goes on the e. Remember, that's not a letter. It just stands for 2.72, just like pi stands for 3.14. And then my answer is x, so it equals x. Put this in your calculator, raise e to the first power, and you get this unholy mess right here. All right, check it, put it back in right there, take the natural log of that number, and you should get 1 to check. All right, what if the natural log of x equals 0? Well, they're telling me what the exponent is. I don't need this equation. I'm going to take it back and make an exponent equation. Here's my exponent. It goes on the invisible e, like that, and it's going to equal the answer, the product, x. Put this in your calculator. x equals 1. Check it by putting a 1 in there and seeing if it's still equal. And then finally, the last one, natural log x equals 1.92. They're telling me the exponent, so the log equation is not needed. Let's take this information back over here and put it into an exponent equation. This is my exponent. It goes on the invisible e, like that, and it equals the answer, or the product x. Put this in your calculator. I rounded it. All right. Again, if you want to check your answer and put that number in for x, don't use the rounded number. Use the exact number that your calculator said if you want this to work out when you check. All right, guys, that's it.